Okay, a compiler is a software that can be described as having a front end and a back end. So this compiler is basically a translation software that can be described to have a front end and a back end. So let's see what we mean by the front end and the back end. Okay, if you take a look at this diagram, up till this point, before this point is the front end of the compiler. This is the front end of the compiler, and all of this activity after this point is what is done at the back end of the compiler. So in the front end, the source code is read line by line. The source code is read line by line. This source code is analyzed, right? So that one single line is analyzed, and then we go back to read the second line. Then that second line is analyzed. Then we go back to read the third line, and then that third line is analyzed. So this is more like a recursive approach, right? We are going through the same procedure time and time again. We are reading line by line. We are analyzing each line, and for each line we are generating the intermediate code. So we are reading each line, we are analyzing each line, and then we are generating the intermediate code. So this is what's happening at the front end of the compiler. This is what's happening at the front end of the compiler. Okay, let's quickly understand the difference between the compiler and the interpreter through this diagram. Real quick, in this diagram, once the intermediate code is generated for a single line, the interpreter is going to interpret and execute that code. So the compiler will end up creating an object code, right? So this is the direction in which the compiler goes, right? So this is the direction in which the compiler goes once the intermediate code is created. However, what the interpreter does is interpreter takes this route. Interpreter comes here, it interprets that code, it executes that code, and then it goes to read the next line. So interpreter executes line by line, whereas the compiler would create the entire object code. So that's the difference between an interpreter and a compiler. Okay, so now what we're going to do is we're going to take a look in detail on the front end analysis that the compiler performs, right? This front end stage of the compiler is what we're going to analyze in more detail. In the front end analysis of the computer, there are when the compiler is basically analyzing the code during the front end analysis stage, there are 4 stages. There is the lexical analysis, there is the syntax analysis, there is the semantic analysis, and finally there is the intermediate code generation. So these are the 4 phases of front end analysis that is carried out by the compiler. Okay, and this is the detailed diagram showing the front end analysis in more detail, right? And as we can see here, there is the lexical analysis that's carried out first, then the syntax analysis, then the semantic analysis, and then the intermediate code generation. So in lexical analysis, each line of source code is broken down into tokens. So let's take a look at an example. For example, if our source code has this variable declaration that we see here, then this can be broken down into 5 tokens. This would be 1 token, second token, third token would be this colon, right, and 4th token, and this 5th token would be this semicolon, right? So this would be the 5th token, right? So this is going to be broken down into 5 tokens, and what you should note here is that this token, this word var, is a keyword. This has a special meaning for the compiler, right? Likewise, this word integer is a keyword. So there are basically categories of tokens, right? And this count is basically an identifier, right? This count is the name of a variable, right? So this is a different category of a token. These keywords are different categories because keywords have special meaning for the compiler, and these signs, these operators, these signs that we see here, the colon and semicolon, are a different category of tokens. Okay, let's quickly analyze one more statement and let's see how many tokens do we have here. This %mark is an identifier, right? And this is one token. This starting bracket, because this is an array, %mark is an array, and therefore the starting bracket is one token, so we have two tokens. This count is acting as the index in the array, so this is the third token. This bracket here is the fourth token. This operator here is the fifth token. This is the assignment operator, right? And this is the sixth token. This core variable, right? This is also an identifier, so this is the sixth token. This multiplication operator here is the seventh token, and this constant is the eighth token. So in the analysis stage, each line of source code is broken into tokens, and then the analyzer is going to categorize these tokens. Some tokens are keywords, other tokens are variable names or identifier. So it is going to categorize tokens also. So, and tokens that are categorized as identifiers, so the identifier tokens, so tokens that have been characterized as identifiers are added to a symbol table. Now the symbol table is what you've already studied in A1 also, you know, symbol table is something like the identifier table, right? And this table is going to have, so this symbol table which is going to be used by the compiler is going to have, you know, the identifier is going to store the identifier, right? It's going to store the identifier. So this is where the name of the identifier is going to be given. Then, you know, it's also going to store the data type. Then this is also going to store the line of declaration where it is declared, right? So on which line of code was this declared, so the line number is also going to be stored here. And then where in the code is this identifier being assigned a value, right? So the line on which the assignment is also taking place is going to be stored in this symbol table. So the symbol table will contain lots of information about the identifiers, and, you know, basically first the tokens are going to be created. The tokens are basically going to identify these tokens are going to be categorized. Some of these tokens are going to be identifiers. For these tokens that are the identifier tokens, the symbol table is going to be created, in which the name of the identifier, the data type of the identifier, the declaration on which line of the code was this identifier declared, and the assignment of value to this identifier, on which line does that assignment take place, is also stored in the symbol table. Okay, now that the lexical analysis has been carried out, the tokens have been produced, the symbol table has been created, the symbol table and the tokens are given as input to the syntax analysis stage. So the syntax analysis stage, in the syntax analysis stage, grammatical errors in the source code are checked. So this stage checks grammatical errors in the code. For example, it checks if keywords have been spelled properly. It checks if keywords have been spelled properly. So that's one of the checks that is performed during the syntax analysis stage. During the syntax analysis stage, it is also checked if an opening bracket has a corresponding closing bracket. So opening and closing brackets are checked. it is also checked, for example, if an operator is missing, for example x plus y equals 6 was mistakenly typed as xy equals 6, right? So there's an operator missing. So these kind of errors are also, this is a grammatical error which is also identified during the syntax analysis. Also during the syntax analysis stage, a parse tree is created for assignment statements. A parse tree is created for assignment statements. So a parse tree is created for assignment statement. Now one thing that I forgot to tell, and let me quickly mention it, these tokens were also input to the syntax analysis, right? And these tokens are going to be grammatically checked one by one. For example, some of these tokens were keywords, right? So the spellings of those keywords are going to be checked, right? It is also going to be checked, for example, on one line you've declared an identifier such as count, and later on that same count you're using in another line and you have misspelled count as CONT, right? So these kind of errors are also going to be detected by the syntax analysis stage. Okay, so let's take a look at an example of a parse tree that is created for assignment statements. So a parse tree that is created for assignment statements. Example would be y is equal to 2 into x plus 4, right? So how is a parse tree going to be created for this kind of an assignment statement? A parse tree such as this is created by the syntax analysis stage, and what this is doing is it is giving the order of precedence in which this statement is going to be executed. So first, on the left hand side, first this 2 is going to be multiplied with x. The result of this is going to be added to 4, and finally we are going to assign this value to y. So this parse tree is telling the order of precedence, the order in which this execution is going to take place, in the order in which this expression is going to be calculated. That's the better way of saying it. So among the many things, as a result of syntax analysis, the parse tree is created, and then this parse tree is handed over to the semantic analysis phase. Now let's take a look at what the semantic analysis is going to do. So during semantic analysis, it is ensured that data types are used in a manner that is consistent with their declarations. So for example, this would be invalid, right? So if you're adding for example an integer value, right, to something like a string value, right, so this is something that is not allowed. So data types should be consistent. So these expressions, right, and their associated data types, is there something wrong here? Are we using these data types in the incorrect way? So this is what the semantic analysis is going to do. So it is during this stage that some meaning of the code is tried to be established, right? And let me explain that. What we do is we create something that is called an annotated syntax tree. This is something that is created as part of the semantics analysis stage. And let's take a look at this annotated syntax tree. What does it look like? Remember, this was our parse tree from the syntax analysis stage, right? This was the parse tree that we had created. Okay, so the annotated syntax, so the annotated abstract syntax tree would look something like this. We're going to create something like this. This would be an ID. This would be equals to sign, right? This would be the plus operator. This would be the star operator, and then this would be a constant, right? This would be an identifier, right? And this would be a constant once again. So something like this. I'm just trying to give you an idea. So this annotated abstract syntax tree is created as part of the semantic analysis. Okay, now that the semantic analysis has been performed, the annotated abstract syntax tree has been created. It is time now for intermediate code generation. Okay, during the intermediate code generation, an intermediate code is created by the last stage, which is obviously this intermediate code generation stage, right? This is the last stage of the front end analysis of the compiler. Remember, we said that the compiler has the front end and the back end, right? So we are discussing the stages in the front end of the compiler, right? And one of those stages, and the last stage in fact, is the intermediate code generation, right? And an example of what this stage does is, by taking a look at this expression says that y is equal to a plus brackets b into c minus d bracket close divided by e. So what this intermediate code generator is going to do is, it is going to convert this code into a 3 address code. What do we mean by that? See, what it has done is, it has declared a variable temp, and b into c has been assigned to this variable temp. So now this expression only has 3 variables, so to speak. There is one variable temp, there is another variable b, and then there is another variable c. So first this is solved. So temp will now have the value of b into c. Then this line, which is basically, now this becomes temp, right? So then temp minus d is the next statement that is executed. Once again, now we have this 3 address code approach. In fact, we are using 2 variables now. So we have d and temp, and the result is stored into temp. So all of this bracket, right? So y was equal to a plus b into c minus d divided by e. So all of this bracket has been solved, and the result has been stored in temp, right? So what we effectively have now is y is equal to a plus temp divided by e, and this is solved. Then temp over e becomes equals to temp, and once this has been solved, y is equal to a plus temp. So what we've seen is that it has broken this expression down, and it has simplified it by having a maximum of 3 variables in any expression, and that is how the entire expression has been calculated. So this is something that the intermediate code generation, this phase does. It generates an intermediate code. That is the simplest definition. It generates an intermediate code, and this is just one example of the kind of things that are taking place within this phase. So now that the front end analysis is complete, the back end synthesis stage begins. Okay, so if there are errors in the program that have been discovered during the front end analysis, so if errors have been discovered during front end analysis, such as syntax errors, then the only job during the back-end synthesis stage is to throw out a list of errors. So the compiler throws out a list of errors that can be seen by the programmer. That is what happens when the code doesn't compile, right? So if there are errors that have been discovered during the front end analysis, such as syntax errors, then the compiler is going to throw out a list of errors during the back end synthesis stage. And in case there were no errors, so in case there were no errors during the front end stage, so there were no errors detected. If no errors were detected during front end analysis, right, during front end analysis, then the main task of the back end synthesis stage, is to produce machine code, right, from the intermediate code, right. So the intermediate code was the last thing that was generated during the front end analysis, right. So the machine code is now going to be generated from the intermediate code. Now an additional step that might be required after machine code generation or during this is that this machine code may need to be optimized. So back end synthesis stage also optimizes machine code. So it also optimizes code. Let's take a look at an example. Let's say we have a for loop, right? So something like this, right? I'm just trying to explain what code optimization means. So we are saying for I is equal to 1 to 10, and this is where we are saying end for, right? And in here we are saying x is equal to 1, right, and temp is equal to temp plus x, So this instruction will always set the value of x equals to 1, and then temp will add this x to its own value, right. But this is unnecessary. As we can see, the value of x will be set equal to 1 10 times unnecessarily. Why can't we shift this x is equal to 1 outside the loop, so that this gets executed once only? So these kind of things are part of code optimization that is also done during the back-end synthesis stage. I hope you've understood how all of these stages work during the compilation of a program.